So here's the first question. We want to know the exact value, and that's just a ratio fraction for cotan theta. If sine theta is worth negative a half and cosine theta is bigger than 0. So sine theta being negative, if you write down your ASTC quadrants, and you know that sine is positive in quadrant 1 and quadrant 2, we want to know when sine is negative. So that's going to happen either in quadrant 3 or in quadrant 4. And then we get some more information from here, and that says that cosine also has to be positive. And cosine being positive only happens in quadrant 4. So I now know which quadrant I'm dealing with. It's an angle that's in quadrant 4. And in this angle, I know the opposite compared to the hypotenuse. And the opposite is -1, and the hypotenuse is 2. And by Pythagoras, I could figure out the missing side. So the missing side is 2 squared is the same as -1 squared plus x squared. So 4 is 1 plus x squared, and 3 is x squared. So x is positive or -3, but I'm in this direction, which is in the x value of being just positive, or it's a length, so it's the square root of 3. So now I have that missing side, and now I can go and do my last step, which is, what is cotan? And by the definition, cotan is the reciprocal of tangent. It's x over y, and so I need to know my x value, root 3, and I need to know my y value, -1, and so the exact value of this angle, the exact value of this ratio of the angle is negative the square root of 3. Let's take a look at another example. Okay, we want to try to find all the angles of theta such that tan theta is 3/4 and sine theta is less than 0. So again, you'll start to see how important this ASTC is. Tan is positive in the first quadrant, where they're all positive, and in the third quadrant, where just tan's positive. And tan, by the way, is y over x, and it's the slope. And so you can see the slope of this line is positive and the slope of this line is positive. Just a little connection for you. And we also need sine to be negative. Well, they're all positive in the first quadrant, but sine is negative in this third quadrant. So I know that I am dealing with a reference angle, a solution angle that's in this third quadrant, and I know that y is 3 and x is 4, and it turns out they're both negative. So this is a little bit misleading that tan theta is equal to 3 over 4. It's really -3 over -4. And by Pythagoras, I could figure out my r value, so I could go and do that. I don't really need to for this question. All I need to know is, because I'm not calculating a trigonometric ratio, I'm not calculating a fraction for this one, I'm trying to find the values of theta that land me with this terminal arm right here. And so you can kind of see that you go 180 degrees plus however far this is. So let's see if we can calculate just this one. Well, you can, and you can do it just using simple trigonometry. You can just go back to what you've learned a long time ago, which is to solve a tan ratio, you use the inverse tan button of 3/4 on your calculator. And so you'll get a solution to this. Now, we have to be a little bit careful with this one because it doesn't say whether or not we're supposed to be in degrees or radians. So I will be more selective in my wording, and I will say all values of theta in degrees or in radians. But just for practice, let's do both. So for degrees, I got 36.87 degrees. Now, it also didn't tell us how many decimal places to go. If I did it in radians, I got 0.64 radians. There's no units for radians. So again, this one's in degrees, this is in radians. But that's only this little tiny angle. I have to add 180 degrees to the first one. So adding 180 gives me 216. And I have to add pi to the second one, which gives me 3.79 radians. Now, I have to also find all values. And in the last section we saw, well, if this is one solution or one angle, there's another one. All I have to do is go around the circle again. Those are called the coterminal ones. So if you have, and I missed the degree sign there, if you have a degrees answer, you can just add 360 degrees to that, or subtract. So, and you can do that as many times as you want. You can spin around once or twice or 5 times. So I'll call that n, and I'll say that n has to be an integer. And the reason that n's an integer is you could go 0 times forward and backwards. You could go -3 times 360, which would be backwards 3 times. And the exact same reasoning would lead to this one being added or subtracted by 2 pi n times, where n is an integer. These do get a little bit tricky, these questions, so we'll definitely need to have some practice. That's the end for this section.